होगी ना.
All right. Looks like we are live. Let me just confirm on YouTube. Okay, yeah, we're live. um, Hello, Sherry. How are you doing?
I'm good. How are you?
I'm good as well. How's your interest in the whole world of blockchain and NFTs going right now? I heard you
Very,
were trying to build
very,
some NFTs in the
very,
past.
very low. Very low.
Very low. It
I've
was
hit,
high about a week ago when I
I've,
saw a snap from you of generating some NFT art. If I'm
uh, I- I've hit a plateau now, so I'm trying to get
hit
out of
the
the.
plateau now.
I'm trying to get out of that plateau, starting right now.
Man,
So,
the plateau is. Do you know the Dunning Kruger effect?
uh, please explain it to me.
I will explain it to you real quick. Let me just share my screen real quick. Um, the Dunning Kruger effect basically is my screen's shared, right?
Yeah.
Okay, so I just googled it and I'll open whatever pictures of it. It's what all of us can relate to. Really, this is a chart where if you take something new, whether it's a skill set, a Udemy course, something you're trying to learn on YouTube or whatever, there's a chart where the y-axis is confidence and the competence is on the x-axis. And when in that first month you learn so much about this new technology, this new programming language, this new whatever, and you reach this peak where you think it's called the mount of the peak of Mount Stupid, where you think you know a lot and you're excited, and then you actually realize how much there is actually to learn. And there's that valley of despair where you basically, this is the point where basically most of the people quit their New Year's resolutions, their Udemy courses, whatever new skill sets they are trying to learn. Can you relate to this? Sherry, are you still with me? Looks like you're muted. Sherry, are you with me? Hello? What's happening? Okay, well, this is the Dunning-Kruger effect, and I feel like about a month into the my exploration journey of smart contracts and the blockchain technology in general, I feel like right now I'm somewhere over here. I'm somewhere around Mount Stupid, the peak of it. I'm somewhere around this peak right here, and the valley of despair is not far from me. I'm about to take this fall, but I want to take this plunge knowingly, with mindfulness, so that I can come out of it and
Oh,
hit.
I'm in the valley of despair right now, for sure.
Yeah, yeah. So I think you went mute for a second. But I
Yeah,
was,
no.
but I was hoping that you were still connected, right? But I was asking you whether you can relate to this, because this happens to me every single time I'm trying to learn something new.
Yeah, yeah. I'm trying to get on the slope of enlightenment, hopefully it starts
Yeah,
again.
it's tough to get there, man. But that right, falling off the Mount Stupid, is that happens every time. And around 1 month or 1.5 month of learning something new is when I reach this peak, when I think I know a lot in the start, all the general basics, fundamentals, and then when you realize how much there is actually to learn, you enter the valley of despair. But let's stop talking about that and get into what we want to discuss today, which is smart contracts. Um,
Yes, sir.
why don't we start with just our basic definitions of smart contracts? What is
Enlighten me, sir. Enlighten me.
um, so I look at it this way. The simplest way to put it is, it's a set of promises or conditions governed by code and not governed by English language written in paragraphs by a lawyer. So it's a set of promises or conditions governed by code, and it has protocols. What's protocols? Protocols is the ability to fetch information, ability to fetch information from a source of truth, from a you know optimally, ideally from a decentralized source of truth. And you can have if conditions, and basically it's a Turing complete thing, which means that it can have its own logic. It can have if else conditions and follow a logic. That I believe is a smart contract. And a lot of my this simple smart contract definition I took from someone else's definition, who explained it pretty nicely in a course I'm taking right now. What's your stance on it, Jay? What's a smart contract, or what do you have to say maybe about what my
Uh,
definition was?
I don't know too much about this, but from what I have understood up till now is uh, a smart contract is basically uh, a binding agreement between party A and B, and there are a set of rules uh, defined in that contract, and when those rules are satisfied, an action takes place
Yeah, automatic.
uh, automatically. So there is essentially the smart contract is taking out the middleman, uh, who the middleman basically in today's world is establishing the trust and it basically enforcing.
Yeah.
Let's just take Uber for an example. We're getting into a stranger's car. Um, what is stopping me from just getting out of that person's car and not paying him at the end of the ride? Uh, Uber is essentially that middleman
Hmm.
establishing that trust, taking
Yeah.
the money from me and sending it over to the driver. In that process, taking their own fees and maintenance fees, service fees, and whole loads of other things.
Yeah.
When if you replace that with a smart contract, now there is no Uber involved. So let's say if there is an agreement between me and the driver saying, okay, when you get me from point A to B, I will send you X amount of money, not more, not less. And you can go into more complexity from what I don't know. I could be completely wrong from, but this is what from what I understand. It could be a very basic contract, just as in okay, get me from point A to B. It doesn't matter how that A to B becomes true. You could fly me there, you could carry me there, or on your back. You could do whatever. Just get me from A to B. Then, if that is satisfied, the money will be transferred.
Hmm. Hmm.
Or you can go into more complex detail as such. Okay, you have to get me from point A to B within 20 minutes
Hmm.
in a car of this type, etc., etc., etc. And you can build on top of it. So
Yeah.
when all of those conditions are satisfied, you will be paid.
Yeah.
I got there was an example in a podcast I was listening to. So
Okay.
basically, so you're a guy is paying someone to shovel snow off his yard.
Hmm.
So when you're paying the guy to shovel snow off his yard, you're just saying, okay, shovel snow off my yard, and you will get this much money within this
Yeah.
much time.
Yeah.
The contract now it's up to the person who's shoveling the snow to decide. Okay, I can shovel the snow with a shovel. I can just use a flamethrower to just evaporate the whole snow. The
Hmm.
guy hasn't told me like what happened. He just told me I should get the snow off.
Hmm.
He doesn't say how I. So where I'm getting at is it can be very basic or it can be very complex, and the contract is just ensuring that this takes place at once all these conditions are satisfied, the funds are transferred or an action takes place.
Yeah.
So it's basically uh, I don't know how to
Yeah.
phrase
No,
this.
absolutely.
You understand,
That's a
right?
pretty good breakdown of the different components, possible components of a smart contract. Now, smart contracts were introduced by the Ethereum white paper written by Vitalik Buterin. Is that how his name is pronounced? Vitalik
Uh,
Buterin.
I think
Um,
so.
he proposed Ethereum's white paper in 2016, um, building smart contracts for DAOs and DApps on top of Bitcoin, which was Satoshi Nakamoto's invention. That's the way he introduced blockchain to the world, which is basically a decentralized ledger, right? And the way I understand it, and I previously mentioned, was that Bitcoin also has the ability to have a smart contract, but it was very simple. It's very simple and it's not Turing complete. The Ethereum smart contracts are Turing complete, so you can actually build logic into a smart contract, which is what all you were talking about, right? All that if and else, all that conditioning can
Yeah.
be put into that smart contract. And so the smart contract resides on the ledger and on an address on the Ethereum or whatever blockchain it's on, right? It's on one single address, every smart contract. Is that how it's played out? I believe.
I'm not sure. So,
So that is how it's done. If I deploy a smart contract to the Ethereum network, then the only thing that I have as an identity of that smart contract on that blockchain is its address. And the way to interact with the smart contract is you need its address and you need to send it something. So you need to fund it
oh,
by whatever fund me variables that smart contract governs in. So I've been playing around with some smart contracts. I'm taking a couple of courses, about 30 to 40% in both of those courses, and I've built some basic contracts. And basically, contracts have I'm playing with Solidity right now, which is a programming language that helps build smart contracts on an EVM compatible blockchain. So Ethereum is, of course, EVM compatible. EVM means Ethereum virtual machine. And then there's a lot of these new chains that are coming out, like Polygon and Solana and all of that. And they're also EVM compatible. They're not Ethereum, but they're EVM compatible. The good thing about that is that all the developers that are developing on Ethereum can also develop on these new chains. So they don't need to learn new languages or technologies to develop on these new chains, which is pretty nice. That Vitalik not just introduced Ethereum, but also EVM, which now new blockchains reside on. So everyone doesn't have to learn like crazy, like completely new technologies to be working on, like, let's say, a newer blockchain, because Ethereum is so trafficked out right now.
oh,
Um,
that's interesting.
yeah.
Yeah, I never understood the smart contract address residing. I understood like okay, it was there, but I never like got into it.
Mm.
But now it makes sense. Like so,
And let me quickly
yeah. Would it be possible like if you could put like a picture up or something? Yeah, I
yeah, let me
understand that.
I am
Uh,
about to pull this picture up. Let me do the entire screen 2.
a side story about this. Because the all of the NFTs and all like there's so many coming out and it's
Mhm.
really hard to get your hands on them. Uh, what people are doing is kind of like a hack. I never understood it until now. Basically, going to the blockchain, like I think Etherscan or somewhere like that. That's
Uh-huh.
where like you can get the addresses and like see
Exactly.
what all transactions are taking place and just copying the smart contract address and
Yeah.
directly interacting with the smart contract rather than going through a website
Yes.
and doing it just eliminates all that.
Yes, that's the low level way of doing it. And so this is a smart contract, and it's written. Well, this is a whole kind of an application. I'm using. There's two different big tools that are being used to develop smart contracts. There's the JavaScript side of things, where you can use Node Hardhat, and Hardhat is, let's open Hardhat. This is if you want to just stay in the JavaScript environment. You use Node Hard Hat to develop your smart contracts and your applications.
What is this? What is this? What
It's
is
a
this? I,
framework to develop, test, and deploy smart contracts.
so
You basically work. Your scripts are in JavaScript, but your contract is always in Solidity, which is the programming language for the Ethereum virtual machine. So Hard Hat basically it's a framework that allows you to build smart contracts. So it'll provide you local toolchain. So it'll provide a node on your local host so that you have some wallets, a blockchain node to play around with locally, and it will also allow you the ability to deploy your contracts on either a local node or somewhere out in like an actual blockchain in one of the Ethereum test nets or something like that. And so that's what Hard Hat is helping you with, basically building a dApp, building smart contracts and deploying it. And the Pythonic way of doing it is, so the Python equivalent
Hard Hat.
of Hard Hat is Brownie. Brownie is allowing you to again deploy, test, develop smart contracts, and do, and it's a whole framework built around that. But whether you use Brownie with Python or JavaScript and Hard Hat, you still have to have your contracts right here. I'll go to my contract in Solidity. So you see that this SOL file, your contracts always are in Solidity. Solidity kind of is a high level, object-oriented kind of language. I feel like it's close to JavaScript, closer to JavaScript than it is to Python. And just like you instantiate a class in any other programming language, there's a contract keyword over here, and so the class over here is the contract itself. And I'm not, without getting into too much details, if you look at this method over here, if you whatever the method name is or whatever its access modifier is, whether it's public, private, whatever, if it's payable, that means this method is going to take Ethereum or whatever currency is being used by the user, and however whatever cryptocurrency the user has in their wallet, they're going to pay this contract via this method. So whatever method has a payable signature means that this method either takes money or gives money out from the smart contract.
Okay, so I'm just reading this right now.
Yeah.
So function, fund, public, payable. So this pay. Can you name it anything, or does it have
Yeah,
to be
this
payable?
is the name, and you can name it anything.
Okay,
Fund
okay.
me. This
Yeah,
can be anything, but this payable is what governs, what tells the contract that, hey, if someone calls
yeah, payable.
if someone calls this contract's address and fund me this method, then expect some ether or expect some token, however much I want. So this is a require keyword. Require is also
Yeah,
native to Solidity. Then I require a minimum USD. So whatever you want to set, this is just a variable, right? I set this amount. So I
yeah.
require this amount to be part of the fund if someone calls the fund me method, and that's how they will invoke a contract, and then they can use the rest of the contract to do whatever in the contract. And then similarly, there's a withdraw method, and as you can imagine, the withdraw method also comes with a payable.
Could you scroll back up? Could you go back to the payable method?
Yeah,
Okay,
fund me right
before.
here.
Okay, yeah, yeah. Could you go on the top? What is before the payable method?
So all of this, these are
Yeah.
basically kind of your most of your public variables that you're going to be
Okay.
using in this
Okay.
contract. And so this and just a quick segue, it's so interesting that I'm learning about gas fees and all. And
Yeah.
so to make your contract gas efficient, you have to use the least amount of variables and do the most amount of work with them. And also, you can, in Solidity, you can have variables go into memory, which is that these variables will only stick to will only be alive for the duration of a function. Or you can go into storage, which means that these variables will be persistent. And there's laws that govern how memory and storage are different, but basically this and these variables kind of affect the gas fees a contract is associated with. The more variables, the more chunky and trafficked the code is, the more your
Okay.
gas fees are. So that's why it's a very important thing in smart contract development to first build but then optimize your code, because in this in any other software engineering terms, optimization usually just means, okay, your code will run faster, right? But
Yeah.
over here, optimization literally connects directly to money, because the less optimal your code is, the more gas fees your users will have to pay when they interact with your smart contract.
Okay.
So coming back, these are just some public
I
variables.
a, a
Go ahead.
question on the variables. Okay, so I want to break them down just to understand. Okay,
Okay.
mapping address to amount. Okay, I get this. It's basically you're finding the address. Could you go
Yeah.
up? Okay.
This is this is a
Right
dictionary.
now, right now there is the address variable. There
Mhm.
is the funders variable. There is the owners variable. What is price feed?
Price. So price feed is what is basically coming from. Let me switch my tab. Can you see this Chrome tab now?
Yeah.
Oh, actually, this is not it. Give me a second. I lost my tab, the hard hat. Okay, so this price feed is an is data coming from an Oracle network. Now, what are oracles? Often, like very often, almost all of these smart contracts that are all out there are hybrid smart contracts. The reason they're hybrid smart contracts is because they're not truly decentralized. Just like any contract in the world needs data from the outside world, smart contracts, as you can imagine, also need data from the outside world. So but they can't just reference APIs, right? Because that would
Yeah.
make them decentralized. That would mean that server, whatever that server is that contains that API, right? That's sending the information back, that server needs to be trusted, and it can't be trusted in the world of blockchain. So in the world of blockchain, APIs are called Oracle networks, and they have to be more than APIs. They have to be more trusted than APIs. So they're basically decentralized APIs that are called Oracle networks. And Oracle networks is what will provide you data from the outside world. Oracle's networks are what provides a contract data from the outside world. And Oracle's networks themselves are contracts on the blockchain itself. So every Oracle networks has its own address. And to put a picture over here, um, um, behind this whole segue that I went to, there's Chainlink data feed. So Chainlink is one of the biggest smart contract facilitation programs on Ethereum. Chainlink basically allows you to really customize your smart contract a lot, and it allows you a lot of oracles. And what oracles are is basically data feeds from the outside world to help your contract make some decisions. So these can be a lot of things. Like let's say I have a smart contract that says to my insurance company, hey, you're going to pay me every time it rains, because it ruins my crops. For some reason, the rain ruins your crops. Okay.
Okay.
And now how does the smart contract know that it rains? It can't just query a weather API somewhere on a
Yeah.
server, because then you're
Yeah.
trusting that server, and that makes it the whole deal decentralized. So
Yeah.
there are Oracle networks that will provide you the same information that the weather API will provide you, but in a decentralized fashion. So every Oracle network is constructed in a decentralized fashion, where they will provide you data, but you don't have to be trusting on one single server for that data. So that's
Oh.
basically an Oracle network. And the reason it's tied over here is because this fund me contract and this fund me method needs an active Ethereum to USD conversion at the time of when the contract is being invoked by the person, right? because you can't hard code that. It needs to know what the current Ethereum to USD conversion is, and so this aggregator v3 interface is just an API, just an Oracle network, which is providing the current price feed, current ETH USD price feed to the network, so the network can judge how many dollars came in and what that dollar amount is equivalent to in Ethereum.
So back to your weather example.
Yeah.
So right now, this is just a basic
Yeah.
transfer of funds. Okay.
Yeah.
Uh,
Basically, you fund me, and then when you call withdraw, that money
yeah.
comes back to your wallet.
So right now, technically, I don't know what term I should. This is like a API that basically giving you a conversion of
Yeah, but
the Ethereum to USD. But
yeah,
if you
you
have
have to
more,
call it an Oracle though, because
okay, okay,
some people
all
are
right.
making jokes out there saying if you call Oracle's APIs, then you're like kind of insulting them.
Oh, sorry.
Yes. So,
Uh,
yeah,
okay, so these oracles.
yeah.
Okay, the more complex my contract is, so the more oracles I will have. Basically, this is gonna will it increase the amount of variables I am referencing in the contract,
So
essentially
So
impacting the
every
gas fees?
Oracle you reference is also a smart contract on the chain. So that
Okay,
Oracle will have its own address. But I have the Oracle right
like an
over here,
API, basically.
right, like a local library over here, because I'm running this right now. I'm running the blockchain on my local network, not on a
Yeah,
test network. So because I'm running on my local network from with Hardhat or with Brownie, Hard
yeah.
Hat or Brownie, whatever their local network is, they don't know what contracts exist on the Ethereum chain. So whatever Oracle you want to use, you actually have to download its code and put it in your library. So this is basically that Oracle network, which is providing all the feed.
So
As you can see, it's providing the latest round number, latest timestamp, and basically the Ethereum feed in these variables.
so right now this is on your this is on your computer, right?
Yeah.
So let's say you want to deploy it, you won't
Uh-huh.
have to take this file, right? The mock v3 aggregator, you won't need it because you're just referencing Oracle. Would you still have to like build a file?
Yeah, I would need it in my local computer, in my local project, if I'm running the blockchain locally, because my local blockchain, which is
Yeah. So if you're
uh,
not running the
let me open
blockchain locally,
an
right?
application right here, right? This application, Ganache, it's a tool by Truffle. It gives you a quick little blockchain. So Ganache, Hard Hat also does it, but
Yeah.
Hard Hat puts it in your command line. What Ganache does is it gives you a little UI over here, right? So
Okay.
that's why I'm not working with Hard Hat right now. So Ganache and quick start my Ethereum blockchain. This is an Ethereum node that it just spun up, and it gave me all these wallet addresses to play with. Every wallet has 100 ETH. I wish this was like a real thing, but it's not. So I can go ahead and run my
So this is like a test network basically, right?
Brownie. Uh, let me Brownie run. Let me deploy, and I'll just use my local network. And so you see that it spun up a Ganache node,
Yeah.
and if I open Ganache right now and go into contracts, transactions, you have these two transactions that were a fund me and a withdraw. Um,
Oh, you
so
just did this.
yeah, I just did this. This was
Oh,
this transactions page was empty. And if I run this again, and I open this, now there's 4. So see, this is Ganache just provides a nice UI to look at your blockchain.
yeah.
But
Bas-
if you're working with Hard Hat, Hard Hat does it just in the CLI. Brownie also allows you to do it in the CLI. If you don't have Ganache this UI installed, then
yeah.
Brownie will just also spin up a CLI blockchain node and run and deploy
Okay.
your contract on that.
Okay, got it. Got it.
Yeah.
Interesting.
And then the next step when you're done with the local deployment is that you go on one of the Ethereum test nets, which your MetaMask wallet is also aware of. So if you just uh, click on this networks tab, it will give you the MetaMask wallet will give you all these test nets. So I'm on the test RinkB network right now,
Yeah.
and there are faucets that will give you free Ethereum to test with, and you can so you can actually test on an identical Ethereum network, not just local. That's the next step of testing. But that was a long segue, I think. But thank you for the great questions. I feel like we
Yeah. So,
spent some good
uh,
time
uh,
analyzing this smart contract on a high level.
yeah, I'm like I was aware of all of this sort of, but I just wanted to like get a better
Yeah. So
understanding of
and
this.
just to wrap it up, this is my Brownie project, right? So that's
Yeah.
I'm telling you that everything's being done in Python. Even the Solidity code will always be like the smart contract code will always be Solidity, but
Yeah.
everything else, the actual deploying of the smart contract is being done, and my getting wallets and spinning up a Ganache chain is all being done in Python. So I'm doing the deploy in Python. Similarly, I have a JavaScript project that is only using Hardhat and Node, so there's no Python files. As you can see, there's still my contract is still a Solidity file, but my
Yeah.
script is this time a
The deployment,
JavaScript script,
the
which is
deployment script.
deploying my contract.
Okay.
So you can work with either JavaScript or Python, but these are the two main big boy tools that are being used, Hardhat and Brownie, out there right now for smart contract development. But yeah, you do need to know Solidity. And that's and just to finish it off, the one last thing, since I've spoken about knowing Solidity so much, this is the course I'm on to, and as you can see, I'm at 6 hours right now, taking my sweet time on it. And this last project was Brownie Fund Me, the one that we were just
Yeah.
talking about. The next one's a lottery, and then they also build a Kickstarter uh, page where the contract will take Kickstarter funds from everyone who wants to invest in the Kickstarter and all of
Hmm.
that. But yeah, that's it.
Okay.
I'm
Okay.
gonna
This is
stop
where
for now.
let's talk about layer two. So,
Um,
what what is layer one, layer two, and then layer three? What are all these layers? Like,
so I'll give you my initial understanding of layer one and layer two, and I'm not exactly sure if this is correct, but that's what I understand is happening. Layer one is the term that's used to describe the underlying main blockchain architecture. So, according to my understanding, Bitcoin would be layer one.
okay,
It would be a layer one network, right? Layer two, on the other hand, is an overlaying network that lies on top of the underlying blockchain. So uh, I'm not exactly sure what comprises of layer two, but that's what like the general I think definition is. The layer two is the main underlying blockchain, and any overlying network that's built on top of the blockchain is layer two.
okay.
But let's get more into it because that's all I know. Maybe we pull up some charts or an article or something
Yeah.
that
Yeah.
can
Could you Google layer layer two real quick?
I'm checking. What do you need about? Okay, yeah, I'll share the screen in just a second. I just want something that's like a little visual too, so we can
Yeah.
really understand what's going on. Everyone has these long articles. Do you want to open up an article or like a picture? I guess
Um,
we'd have to.
go for an article.
Okay.
Could you share your screen? Just Google it,
Yeah.
like
Yeah.
layer two, and we can just go through like
Yeah. I'm
whatever
sharing
first
it
level of
right
articles are.
now. Okay. So I just opened a couple of layer one and layer two. Okay. So,
Okay, how about
so
you open up? Yeah,
uh,
discuss.
s- what do you need to know about different blockchain layers? Scalability is the need. Okay, so layer one is the term that's used to describe the underlying main blockchain architecture. Layer two, on the other hand, is an overlaying network that lies on top of an underlying blockchain.
Okay,
Consider,
what is that picture?
huh?
What is that picture on top? The main head.
Layer one. So layer one, Bitcoin, Ethereum, Algorand. Layer
Okay,
two, Omise Go, Bitcoin, Lightning. So is this
okay.
all the cryptocurrency? Would all the cryptos, besides the Bitcoin, Ethereum, be layer two? Like most of these
And I was just going to ask, okay, so Ethereum is layer one. So
Bitcoin is,
the shit coins being developed on top of Ethereum are layer two,
they have to
or
be, right? They
or
have to be.
or or are the applications being built on top of Ethereum layer two? Uh, so
Yeah,
let's
that
say
has
like
to
a
be layer
very
two. Let's see. Let's see. Consider
yeah.
Bitcoin and Lightning network. Okay, Bitcoin is layer one network, while the Lightning network is layer two. Now the four differences. State channels and nested blockchains.
Okay. There's two-way communication channel between participants, which enables them to conduct
That sounds like
interactions.
a smart contract to me,
Essentially,
right?
yeah.
Why isn't
Typically,
he using the word though? I'm
because probably it's. Let's just look into it.
okay. Okay, doing this
See how it's
helps
correct.
in cutting the. Oh, there you go.
Yeah.
Yeah.
What should the
So state channels we can kind of look at as smart contracts. So that means yeah, with what we were our hypothesis like a minute ago when
yeah.
we said all these dApps and shit coins and everything, they're basically essentially smart contracts built on top of Ethereum, right? So they are all part of layer two.
Participants can directly interact with each other without submitting anything to the miner. Uh,
Final transaction over the final state of the channel is added to the blockchain. Yeah, that sounds good.
uh, so
Bitcoin's Lightning Network and Ethereum Raiden Network are the most.
okay, so basically, Bitcoin is only like transactions, shorty like
Yeah,
of money, but uh, Raiden is more complex than that, and you can run smart contracts on that. What could you scroll up? What I don't understand is the minor part of it. Uh, State channels, the last line. Doing this helps in cutting down the waiting time since you no longer depend on third party like miners. What does that mean? Aren't the miners just there to essentially validate the
yeah,
contract?
yeah. Comes in cutting down.
So
Oh, I think they're saying that so because smart contracts when they run immediately, right?
yeah,
They run instantly. And then what the miners' jobs are doing with the proof of work algorithm is just basically adding it to the blockchain after a little bit.
yeah.
Or
They're
yeah,
basically validating the whole
yeah,
contract.
no. So it is still dependent on miners.
I don't understand that. That's what I don't understand, or I'm understanding the whole miner concept wrong. Because from what I understand is miners are there are basically the proof. They are the ones are holding the whole network,
Yeah,
saying
they are basically trying to they're trying to solve the puzzle, the Bitcoin puzzle,
Yeah.
trying to get to the consensus, and everyone is in a race to reach to get mine the latest block. And once
Yeah.
you do that, you get a bunch of you get some Bitcoin. And there is, I believe, every 10 minutes, every 10 no every hour, 6 Bitcoins are mined. So every 10 minutes a Bitcoin is mined. And
Whoa.
it's a little different from Ethereum. Let me I don't want to look at someone else's. um,
Okay, what is nested? What was the nested?
what oh, okay. Currently OMG, which is like a crypto, right, a token, and Ethereum based app is working on a nested blockchain solution called Plasma. And a lot of projects are doing these nested blockchain solutions, I believe.
Okay, the main
They're-
base blockchain is going to lay down the groundwork of the entire system. It will not take part in the occupation unless operational need to resolve some disputes. There will be multiple level of blockchains sitting on top of the main chain. These levels are connected to each other through the parent chain. Not only does the solution significantly reduce the load on the root chain, but I don't understand.
I'm hitting a wall as well.
Uh,
Let's keep on
could you,
reading. Maybe we switch an article and look at someone else's point of view.
okay,
The
later
biggest
solution.
pro is it doesn't mess with the underlying blockchain protocol.
What are what is sharding and consensus protocol changes? Many projects like Ethereum, um, the proof of stake. Could you stay there? Could you not scroll? Yeah, thanks. Ethereum, both are proof of work,
Yeah.
wherein miners have to what is secure. The problem is that it's very slow. Yeah, understood. Only manages 7 transactions. Okay.
Okay. Sharding sounds like parallel processing.
We can go through that. Check off making nervous. Small shard. Okay, yeah. Okay, so basically, what I understood was layer one is the base, and you're building layer two on top of it to improve uh, layer one.
Mm-hmm.
But right now they're saying, okay, there are two solutions. Either you can make a more efficient way on top of the layer one,
Uh-huh.
or you can make layer one more efficient and then go forward.
Something like that. Something like
Something
that.
like that, right?
Yeah. Yeah. That I think that's a good way of putting it.
Because if you go, could you go back to the state channel and the other part?
Say channel and nested blockchain. That's
Nested,
layer two solutions.
the nested blockchain. The nested blockchain part was interesting. So basically, the root chain Ethereum, which is proof of
And
stake, and
a
all
lot
of
of
that.
these crypto tokens, not necessarily shitcoins, are nested blockchains. Uh,
Yeah. So no, no. I think all of these platforms and everything being built, I think these NFTs and all of these things, I think those are nested blockchains because they
yeah.
are being built on top of the root chain. So the plasma contracts, the social networks, micropayments, decentralized exchange, all of this is built on top of the layer one, which is the root chain, right?
Hmm.
So they're saying they want to fix the root chain so that all of these can be even more efficient, right?
Yeah.
And these were essentially the nested blockchains were essentially built to make more use of the rooted chain because the root chain is there.
Yeah.
It's just a tool, right?
Yeah.
And it's how you use the tool. The nested blockchains are using the tool in a different way.
Okay. That makes more sense.
It does that make sense? Because like that's what from what I'm understanding
Yeah.
the
Yeah. No,
blockchain
it does.
to be.
Um, okay. Let's look at
Yeah,
one more person.
yeah,
What they have to say about this, and then we can really, I think, we'll be able to put it together. My
yeah.
a friend of mine works for Gemini. That's cool. Okay.
Could
Layer one.
you
Layer.
could you bring up that article? Could you put out?
Which one?
Could you scroll down? There is one, layer two, and layer three article.
Layer.
Uh, yeah, this
You
one.
could also watch a YouTube video.
Uh, yeah, that would make it much easier.
Why not? Hey, interesting fact. Let me tell you an interesting fact real quick. Okay. So this is the Bitcoin white paper that I read last night for the first time. Very enlightening. I would definitely recommend. I also recommend going and liking my LinkedIn status about it. Now, um, here's an interesting fact. Control F, blockchain, not mentioned a single time by Satoshi Nakamoto. So it was really a word that popped up after Satoshi built his
Oh,
peer-to-peer network. He basically wanted a peer-to-peer network, and which is and its conclusion basically summarizes it so well. Let's just read this once, and then we'll move back to layer two. We have proposed a system for electronic transactions without relying on trust. We started with the usual framework of coins made from digital signatures, which provides strong control of ownership, but is incomplete without a way to prevent double spending. Double spending is basically the problem Bitcoin solved in terms of online ledgers. To solve this, we proposed a peer to peer network using proof of work to record a public history of transactions that quickly becomes computationally impractical for an attacker to change if honest nodes control a majority of CPU power. The network is robust in its unstructured simplicity. Nodes work all at once with little coordination. They do not need to be identified since messages are not routed to any particular place and only need to be delivered on a best effort basis. Nodes can leave and rejoin the network at will, accepting the proof of work chain as proof of what happened while they were gone. They vote with their CPU power, expressing their acceptance of valid blocks by working on extending them and rejecting invalid blocks by refusing to work on them. Any needed rules and incentives can be enforced with this consensus mechanism. I really liked it. I was thinking it would be much more technical, but actually it was like, very explanatory. I'm a fan. Probably gonna read it again. And just to look at it, the Ethereum white paper is so much. Just to compare um, the um, the length. This is a 9-page white paper with the ninth page just being references, and then this is Ethereum, which makes sense. It makes sense that Ethereum's this big, but it's cool. It's cool. I think one of our talks we definitely need to look at the Ethereum white paper. Okay, coming
yeah.
back. Sorry about that. Let's go back to layer 2. This one, I guess it's only 3 minutes and 44 seconds and
Sure.
has a good amount of views.
Sure. Why not?
Or this one. But this one's 10 minutes.
I think the first one should be good.
First one, let's just go, yeah.
If you've tried DeFi recently, you've probably experienced the frustrations of high transaction fees as the demand for DeFi services on Ethereum have increased. And it's become normal to pay higher fees, such as $20 per transaction. I even recently saw $565 for a single transaction. Crazy. And if this blockchain scalability problem isn't resolved, these transaction fees will act as a major roadblock to the mission of banking the unbanked with permissionless finance. And in that case, DeFi really becomes more of a playground for the rich. Thankfully, this is why countless research teams have been working for years on upgrades to Layer 1 with Ethereum, as well as a series of Layer 2 solutions, which act as an overlaying network that lies on top of the underlying blockchain, doing a lot of the work for it. So let's consider Ethereum first. It's the underlying main blockchain architecture, Layer 1. And interestingly, if you're watching this series in 2021, Ethereum only recently launched phase 0 of its long-awaited transition to Ethereum 2.0 and proof of stake, which will mean Ethereum no longer uses a proof of work consensus like Bitcoin, no more miners. That means faster transactions, less electricity burned, and reduces the carbon footprint of the Ethereum network. It reduces centralization risks and a Layer 1 design that aims to be, oh yeah, World War III resistant. Yes, the nerds are building to ensure their technical achievement outlasts them in an end-of-day scenario with World War III in mind. Yes, only in crypto. If the rest of the world is gone, you'll still be able to buy ETH. So what's Layer 2 then? Well, Layer 2 is a collective term for solutions designed to help scale your application by handling transactions off the main Ethereum chain. Layer 1. Now, transaction speed suffers when the network is busy, which can make the user experience poor for certain types of dApps, especially in DeFi and those related to gaming with NFTs. And as the Ethereum network gets busier, gas prices increase as transaction senders aim to outbid each other. And this can make using Ethereum very expensive. So to summarize, we need Layer 2 because some use cases, like blockchain games, just make no sense with current transaction times, and it can be unnecessarily expensive to use blockchain applications. And any updates to scalability should not be at the expense of decentralization of security. So Layer 2 builds on top of Ethereum. It's doing a ton of the work so that Ethereum doesn't have to do it, and then the transactions are written back to Ethereum blockchain. Now, the key takeaway is that 2020 was about DeFi stretching Layer 1 to its giddy limits, which led many in the community to finally understand firsthand just how badly we need scaling solutions. And it's funny how often the answer is right there in front of us, but we just don't go there because it's not that big enough of a problem. But the good news is that many teams with much greater foresight than the most of us have been working on this for years. And it feels like DeFi is the final kick in the butt that we needed to get building Web3 applications on Layer 2. You've been watching DeFi 101. Do be sure and check out the other videos in the series and subscribe to the channel so you don't miss the new videos as they drop. And above all, stay safe out there.
All right.
So
what did you take away from that? I think that was a good explanation. It's basically in helping Layer 1 scale.
Basically, you're taking the stress off Layer 1.
Yeah. So all of these apps and everything are essentially part of Layer 2.
Yeah.
Got
it. Yeah, this is a very I think a high level explanation of what Layer 2 is. But I understand it now. What's the purpose of Layer 2 essentially?
Yeah, the purpose. I think he did highlighting.
Yes. So it's basically scaling it, expanding the use cases, and taking the stress off of Layer 1.
Yeah.
It's very interesting to see when Ethereum 2 comes out, whatever. That comes out, and how these.
The roadmap. Let's see. ETH 2.
I don't think it's going to provide a very concise. It gives you what they're doing, but they have no date, man. It could be.
But what do they say right now, right? Like, what's the? targeting for the merge to occur before June 2022. There's no way it's happening within 2
Nah,
months.
no. They keep changing it, man. They keep changing it. I heard they were coming out in summer, but I don't think they will come out in summer.
So, Sherry, the one interesting thing is, and that the one interesting question in my mind is, and this might be answered if and when we do read the Ethereum white paper. Since see, there's a when you decide to decent create a decentralized ledger, a decentralized technology like Ethereum or Bitcoin, right? What you're essentially doing by decentralizing it is you're killing the ability to update it, to launch updates. Like there's updates in our apps, because you can't, there is no central governing body that's updating the blockchain. So I'm very I need to kind of like look into how they are migrating to ETH2, because you can only migrate if you have the consensus of 51% of the nodes, and there is
Yeah.
no governing body. So, and I'm sure Vitalik has built something related to this, but I'm excited to see what makes this migration even possible, because in the essence of blockchain technology, you can't really migrate, you can't really update the system. So it'll be interesting to find that out, how that's
Oh,
happening.
yeah, that's very interesting. I never thought about that.
Web
Anyways.
3.0. Web3. We are at 56 minutes, so we'll
Yeah,
we'll end it to we'll keep it to an hour like we did previously too. So
yeah.
we'll just summarize for the next couple minutes, and maybe decide on what we want to explore um, next as well.
I'm just pulling it up right now. I'm just looking at it.
We talked about um, smart contracts and layer one versus layer two today. Some of the other let's take things like that are maybe relative to layer two and smart contracts, and
Yeah,
the next. Uh,
uh,
I feel like, I mean, yeah, NFTs are relatable, DAOs are relatable.
okay. So
Blockchain
with
gaming is relatable, security tokens, staking and yield farming. Right? A lot of these are
that,
relatable.
I would say let's sort of like go over the Ethereum white paper,
Okay.
uh, uh, get our
And
takeaways
see,
from
and
it,
then so we can really
or
draw a distinction around
yeah,
what Ethereum did that was so revolutionary. We know that it allowed smart contracts to be built on top of blockchains. That's that we
yeah.
know that as a general thing that Ethereum did. But maybe we could get in, like, read it on a high level and get a nice overview of how Vitalik made that possible. What is the Ethereum virtual machine?
And after that, we can see the layer 2 and layer 3 solutions
Hmm.
that are there right now and what are coming out and all of that to expand, because we have to understand the root to understand what layer 2 and layer 3 is trying to solve
Yeah.
or what's being built on top of it. So I would say that's a good course we could, and then within that there is NFTs and DAOs essentially on
Yeah.
layer. I would that's
Yeah.
layer
They
two.
all come
So
into play at some point.
so I would say let's start at the white paper. I don't think if
Can
you
we
want to go
also do a
ahead.
separate, like a separate talk, just to explore um, and talk about cool NFT projects? Because
Yeah,
that's separate, but I feel like that's just that's more exciting than these
sure,
talks.
sure,
Definitely
sure.
more exciting.
I would say
Um,
let's
yeah,
understand this, and
yeah.
then I think the second step after that is once we're exploring the layer 2 and layer 3 solutions, we're looking at real world stuff. So then we'll just start looking at all the NFTs and
Yeah.
all the gaming,
Okay.
because this year, all stuff aside, gaming, metaverse, and gaming NFTs and all of this, this is gonna blow up. So all
Gaming,
of
I feel like the gaming industry
so
and the artist industry are
not even the artist industry, man. Artist industry is sort of like saturated now. Okay, it's
uh-huh.
done. That was last year.
Yeah.
This year, metaverse, gaming, all of these tokens. So I'm heavily looking into all of these gaming tokens. So right now,
Yeah.
I would say the tokens I am looking into mainly and I'm investing into are like Solana,
Okay.
Sandbox, Mana,
Mhm.
which is a Decentraland one,
Yeah. Yeah. Yeah.
uh, UFO, which is a gaming token.
I
There
own some
is
mana too.
there, there is
I got some
uh,
mana as well.
yeah uh, then there is
I got a
UFO
mana to
token.
myself.
Turn on your camera.
Are we turning it
So
on?
no, no,
Oh,
no,
okay,
obviously,
okay.
yeah. Then there is the Meta coin, which is also good coin. These are all gaming coins, gaming tokens, because essentially gaming is what's going to be big in coming up. Because right now we don't think of this because we don't know this. The kids that are growing up right now who have been stuck at home for the past 3 years, with the third year of the pandemic, have been stuck at home for 3 years, can't go out to play like normal kids and all of that. What are they doing? They're playing online games. They're playing Fortnite, Call of Duty, all these games. So essentially, the
And
new
developing social anxiety.
oh, that's a separate thing.
That's a
That is off the blockchain.
yeah.
So,
Let's not get cancelled.
so the thing is,
Get cancelled
what
before we blow up. Okay, no, but yeah. All right. So next up, Ethereum, and then we draw. And when we complete that, we'll have a better understanding of what what
Sure.
Ethereum allows and what are all these chains that are branching off of Ethereum and that are introducing new stuff, and we can then decide where we go after that.
Sure. I
Okay.
think it's a good point
All
to
right.
end on.
All right.
Okay.
Cool.
Uh,
We will end this now, and Sherry. All right, cool. I'm gonna go ahead and end the broadcast.
yeah, yeah. That's basically the ending music.
ये हम आ गए अपनी औकात. Oh shit!
Yeah.
I knew.